Problem 18. Here we have we have to find the equivalent capacitance of the capacitors in this figure. Okay, as you see here, we can say we can label its branch AB, here B, C, here we have C, D, here we have D, A. Okay, between A and B we have two parallel capacitors. Why? Because V, let's say here we have one. It's better to label each capacitor. 2, here we have 3, and here we have 4. So V1 equals to V2 equals to VAB. So V1 and V2 are parallel. In this case, if we want to add two parallel capacitor, C1 2 equals to C1 plus C2 equals to C1 equals to 6 plus C2 equals to 2. We get 8 microfarad. So here we have, in the place of C1 and C2, we have C1, 2. Okay, here first of all you can replace this one, which is between the point A and B, will be an equivalent capacitor C1, 2, which is equal to 8 microfarad. Okay, okay, now we have three capacitors, C1, 2, C3 and C4 are in series. So I take C4, C3 and C1, 2 are in series. So you know 1 divided by, here I want to calculate C4. Okay, we can say C1, 2, 3 and 4. In the case of a series capacitor, capacitors C1, 2, 3 and 4 equals to 1 divided by C1, 2 plus 1 divided by C3, 1 divided by C4. So we can calculate equals to 1, C1, 2 equals to 8 plus 1 divided by C3 equals to 8, and C4 equals to 8. So we get here 8, 1 plus 1 plus 1, we have 3. So C1, 2, 3, 4 equals to 8 divided by 3 microfarad. So we get finally C equivalent with a simple battery here with delta V equals to 9 volt. Here the C equivalent. C1, 2, 3, 4 is equal to C equivalent, which is equal to 8 divided by 3 microfarad. Okay, this is part 1. Part 2, I have to find the charge on each capacitor. Okay, you know, we have to find part B. I will write here C12 equals to 8 microfarad. C equivalent total equals to 8 over 3 microfarad. Part B, I want to calculate Q of each capacitor. I have to find Q1, as you see here. I have to find Q. Here we have Q1, Q1, Q2, Q3, and Q4. Here, you know, we have Q, we have C1, 2, which is equal to 8 microfarad. Okay, and you know, we can calculate Q of 1, 2. You know, here we have C1, 2 equals to 8. And here we have C4 equals to 8. And here we have C3 equals to 8. And this one equals to 8. So, and here we have 9 volt delta V equivalent. Okay, you know, we have C equivalent and this one is delta V equivalent. This is the total delta V. We can say delta V equivalent. You know, here C12, C4 and C3 are in series. So C12, C3 and C4 are in series. So delta V equivalent equals to the summation of delta V equals to delta V 1, 2 plus delta V 4 plus delta V 3. As you see here, we have, you know, in the case of a series capacitors, we have the same Q. Okay, we can say here Q12 equals to Q3 equals to Q4. Okay, so we have we have C 1, 2, we have Q 1, 2, because we can calculate, in the case of a series capacitor, we can say Q equivalent equals to Q1, Q12 equals to Q3 equals to Q4. At the final, C equivalent equals to we calculated Q equivalent equals to 8 divided by 3 microfarad, and delta V equivalent equals to 9 volt. So we can calculate Q equivalent easily from this relation, where Q equivalent equals to C equivalent times delta V equivalent. So equals to 8 divided by 3 microfarad times 9. We get here 8 times 3. Uh, you can put it directly. We have 8 times 3 equals to 24 micro. The unit of Q is coulomb. This is Q equivalent. So here we have the value of Q equivalent, which is equal to Q4. Here Q equivalent provided by delta V. Here we have Q equivalent equals to Q4 equals to Q1, 2 equals to Q3 in the case of a series capacitors. So we can write directly equals to Q12 equals to Q3 equals to 24 microcoulomb. So I have Q of each one. I have C of each one. We can calculate delta V. Okay. So we can say directly delta V 4 equals to, the relation C equals to Q divided by delta V. So delta V equals to Q divided by C. Delta V 4 equals to Q4 divided by C4 equals to 24 microcoulomb divided by C4, which is equal to 8 microfarad. The answer will be 3 volt. Anyway, as you see here, we have 3 capacitors with same capacitance, 8, 8, 8. So here we will get 9 divided by 3. We must have 3 volt plus 3 volt plus 3 volt. Delta V must be divided to 3 equal voltage because they have the same capacitance. Okay, we can calculate them. Delta V 1, 2, 1, 2, which is equal to Q 1, 2 divided by C 1, 2 equals to 3 volt, and also delta V 3 equals to Q 3 divided by C 3 equals to 3 volt. So here I calculated delta V of C4, C3, and you know delta V 1, 2 equals to delta V1 equals to delta V2, because here, if you see, 1 and 2 are parallel, so they have the same difference of potential. Delta V1 equals delta VAB, delta V2 equals delta VAB equals to delta V12. Okay, this is part B. Part C, okay, we calculated part C and part B, Q and delta V.